Hello.
Welcome to Impulse Mathematics. I am Subhajit Buxi. In this session, I am going to discuss about the basic of calculus. Although in this session, I am not go through the analytical approach, so let's get started. First, we discuss about the calculus. So it's actually invented by Sir Isaac Newton and G.W. Leibniz in 17th century. Calculus has two major branches: differential calculus and integral calculus. So now come to the concept of calculus. Calculus is nothing but change. It can be anything. Maybe it is the change of position, maybe it's change of time, maybe it's change of length, and so on. Now we came to the concept of differentiation and integration. Differentiation and integration are oppositely related. Differentiation is actually a small change that can happen anything with respect to some variable, and on the other hand, integration is actually a small part that accumulating. Here we see that the differentiation is the rate of change and integration is the rate of accumulation, and also we called integration as an antiderivative. So now, how calculus is invented, or why calculus is needed actually? We all know that necessity is the mother of invention. The time when calculus is not there, area of well-shaped region can be found. Area of rectangle like this, length into width. Area of triangle, half base into height. Area of a square, that is length square. But there is a mystery about the area of circle. Actually they all struggle about this mystery. Then there is a conception, so let's check it out. You can see that the circle is divided into four parts. Each of four parts are arranged here in this way, so we get the figure like that. This four part is actually here. If we all know that the circumference of the circle is 2 pi r, and if we divide this circumference into two parts, that is pi r, so this will be pi r and this will be pi r, and as the radius of the circle is r, so here r is the radius. So if we consider this figure as a rectangle like this way, we can define its area, pi r into r equal to pi r square. I know this figure is quite abnormal to consider as a rectangle, so if we divide this circle into some more parts like that and perform the same operation, that is this part is arranged here like this way, so we see that the half of the circumference is here, pi r, and half of the circumference is here, that is pi r, and the radius of the circle is r, so r is here. Therefore, and now we see that this figure is look like rectangle, quite similar to the rectangle actually. So this will be pi r and this will be r, so length into width, length here pi r and width r, so area is pi r into r, that is pi r square. So here this approximation gave us the idea of limit, the concept of nearly approaching. This is the basic idea of calculus actually. Now we check the introduction of the limit. Now definition of the limit. Definition of the limit is behavior of the function in a neighborhood of a particular point. I previously said that I am not going through the analytical approach in this lecture, so this is the definition here. Now we consider a function fx equal to x plus 5 and choose a point x equal to 1 randomly. Then we see that at the point x equal to 0.8, that is neighboring to 1, very near to 1, so fx, the value of fx is 5.8. we take the value of fx is 0.9, then we take the value of fx is 5.9. If we take the value of x is 0.999, then value of fx is 5.999. Here we see that the value of fx is approaching to 6 as x approaches to 1, and this will be happen from the left hand, so we call this as left hand limit x. So this is we call that fx tends to 6 as x tends to 1. Similarly, we can see that at the point x equal to 1.2, the value of fx is 6.2. The point x equal to 1.1, the value of fx is 6.1. At the point of x equal to 1.001, the value of fx is 6.001. Here we see that the value of fx approaches to 6 as x tends to 1. Here the approach came from the right hand, so we called this as right hand limit, and finally we denoted this as x tends to 1, x plus 5 equal to 6. That is, we put the value here, so we get the 6. This is the basic concept of the limit actually. So that's all for today. We will discuss some mathematical problem about the limit in the next session.